So in this video, we look at the second law of thermodynamics, that what is it all about, the forms that it takes, and as it relates to entropy. Now, let's assume we have 0.1 kilogram of water at boiling point. And ice at 0 degrees Celsius of the same amount of 0.1 kilogram. Now, if we are to put these two together in an insulated cup, we will end up with .2 kilogram of water at 10 degrees Celsius. Now, but this is not surprising, is it? Many thermodynamic processes proceed naturally in one direction, but not in the other. So in this example, we would expect heat energy or heat in the form of energy to be transferred from a hot body to a cold body, but not in the opposite direction. Energy in the form of heat flows naturally and spontaneously from a hotter region or a hotter body to a colder body. Naturally, that is the spontaneous direction of flow of energy in the form of heat. Now, we may have observed leaves falling naturally and spontaneously to the ground, but it is naturally impossible for leaves that are falling naturally or fruits that are falling naturally to uplift themselves, attach themselves once again to their plants. It is naturally impossible, and it may happen only through magic or something, but naturally that does not happen. In the same way with the direction of flow of energy, heat naturally flows spontaneously from a hot body to a colder body. It is spontaneous, and here direction is of essence. So to move heat from cold to hot would involve work to be done. So just as we have for fridges where work has to be done in order to pump heat from the cold region to the hot region, it gives rise to one form of the second law of thermodynamics, that it is impossible to transfer heat from a colder region to a hotter region without work. Work has to be done in order to achieve that. Now, another form of the second law of thermodynamics has to do with the amount of heat transferred, and that with the transfer of the heat, part of the heat is lost. Now, most of our energy comes from coal, it comes from oil and gas and nuclear. They supply energy that is transferred as heat. Now, for example, heat engines, as an illustration, it is impossible to build one that converts heat completely to work. That is to say, it is impossible to have a heat engine that has 100% thermal efficiency. So though heat will be transferred, it is impossible to have 100% complete heat transfer. It is impossible to convert heat completely to work. So as with natural spontaneous processes that proceed in one direction, entropy increases. That is to say, in the direction of increasing disorder. Now, let's take, for example, you take a holiday away from home for some time. Now, you come back to find that the room that you left in an orderly manner has become messy and dusty, and that you would require some energy, some effort to clean it up. So by the second law of thermodynamics, as related to entropy, entropy is positive in such processes. But with ideal reversible processes, the entropy can be zero. However imperfect as most systems may be, under natural spontaneous processes, entropy is positive. So we look at the second law of thermodynamics in different forms, under different statements of impossibility, which tends to limit the availability of energy and the ways in which it can be used and converted. So this is the end of my video. Thank you very much for watching, but keep watching.